way as we would with x's or with y's or whatever. The sine and cosine part of it tends to freak people out, but we are still solving by factoring. And one of the things you need to remember when you are solving by factoring is that you have to get everything on one side of the equation and just leave yourself with a 0 on the other side of the equation. So this first example right here, we've got sine squared times cosine on the left, and then we have just a cosine on the right. So like I said, since we are solving by factoring, very first thing you need to do with every single one of these problems is make sure that you get everything on one side with just a 0 on the other side. So we'd be subtracting that cosine from the right over onto the left. Okay, and then there are a couple different factoring techniques that you can use. Any thoughts on how we could factor this one? What do you think? We could do that. In this case, it would actually make it more complicated. There are definitely going to be examples where we're going to want to do that. And that's, I reminded you guys of those up on the board. So there will be situations where you'd want to replace sine squared with 1 minus cosine squared. This one, though, we have a GCF. So if there is a GCF, that's the technique that you want to go for. What's the GCF between these two terms? Cosine. Good. So both of our terms have a factor of cosine, kind of like in any ordinary function having a GCF. So we're going to take out the GCF, and then remember what you do is you kind of leave the leftovers in parentheses after you take out a GCF. So what's left from this term after we factor out a GCF? Sine squared. Minus, and then what's left with this term once we factor out cosine? Just a 1. Don't forget about the 1. Like if you factor something out and it seems like it's gone completely, it's not a 0 that's left behind, it's a 1. Because think if you were to redistribute that cosine, then you would have a cosine here. Okay, so this is like one factor, this is like one factor. So what you do, just like, if you had x plus 1, x minus 3 or something like that, you would take both of those factors and set them equal to 0. So that's what we're going to do here. We're going to take cosine theta and set that equal to 0. And then we're going to take sine squared minus 1 and set that equal to 0. Every problem that I give you, I'll tell you guys if I want your answers in degrees or in radians. So let's say that we want this one in degrees, and then we'll do number 2 in radians just so we can practice both. So degrees for number 1, radians for number 2. But like I said, the instructions I will specifically give you, either degrees or radians or a certain range that I want you to go in. Okay, so this one, cosine theta equals 0. Here's where your unit circle comes in. So I've still got mine. I'm just going to put it up on the screen for you. So we're looking for any angle, and we want it to be in degrees where the cosine is 0. So what am I looking at on this screen? What's the cosine associated with? The x coordinate. So you've got this entire circle's worth of coordinate points. We want the x coordinate to be 0. And it's very possible that there could be multiple answers for these. 270, good. We've got one right here where our x coordinate is 0. 90, we've got another one where our x coordinate is 0, and that's it. So this, when our x coordinate is 0, that's on this line right here. So that would be 90 degrees as well as 270 degrees. Okay, so that's what this equation is asking us for. It's saying the cosine of what angle ends up being 0. So our job is to find those angles. So first we've got 90 degrees, 270 degrees. We've got those, and then we're going to get some answers from the second equation as well. So this one we have a little bit of work to do. Like here we already had the cosine by itself. What do we have to do with this one? Add 1. Okay, so add 1, and then we'll have sine squared of theta equals 1. Then what? Square root. Good. We're going to square root both sides. And when we square root, we should not forget what? Plus or minus. So we have plus or minus 1. So this time we go back to our unit circle. Sine is associated with what? The y coordinate. Good. So now we want our y coordinates to be either positive 1 or negative 1. So I'll get this back up on the screen. So in degrees, what angles would have a y coordinate of either positive 1 or negative 1? Same ones we just had, yeah. So here's a y coordinate of positive 1. That's 90. We actually already have mentioned that one. And then down here, you've got a y coordinate of negative 1, and that's 270. So the 90 and the 270 are just kind of repeated answers. So I'm just going to write in parentheses here that theta is equal to 90 degrees and 270 degrees, because usually we solve them both. It just so happens that each of the equations gave us the exact same answers. Normally we would compile them into one big list for our final answer, but they just happen to give us the exact same repeated answers again. So 90 degrees and 270 degrees would both make this equation true if I were to plug those in for theta. Okay, any questions on that first one? Okay, so second one. This one, what was the very first step that I mentioned you should always do with these? Good, get everything set equal to 0, get everything on one side. So we'll have 2 times sine squared minus 3 times sine. That was already on the left. And then I have this negative 1 that I'm going to add over to the other side. So I'll have plus 1 and then equal 0. Okay, so this one, if we have a GCF, we would factor it out as the first step, kind of like we did with example number 1, but we don't have anything that all 3 of these terms have in common. Without the 1, these 2 terms would have a sign in common, but this one doesn't have a sign. So this, if there's no GCF, then we look to make sure that these match. These should match. Like if this is sine squared, this should be sine. Otherwise, let's say that one of them was cosine squared and one of them was sine or something like that. You can't factor with a mix and match. So that's where you would use this. And Isabel, I think you mentioned this with the first one. If I had a cosine squared and a sine, there's no way to factor that because those are like different variables. So you could make one of these replacements. You don't have to do it with this one, but there are going to be 1 or 2 in today's example problems where you have to do some sort of substitution with one of these. So that's why I wrote those on the board. For this one, it's all sine. So that's kind of like everything being all in terms of x. So one variable, you can just factor it down. So this, we go into our kind of just normal factoring, like 2 sets of parentheses like this. So think factoring, think kind of reducing, or I'm sorry, undoing that FOILing process. So this term right here times this term right here is supposed to multiply to give me 2 sine squared. So what could go here and here to give me 2 sine squared? Yeah, 2 sine and then times sine. So if I have, let's say 2 sine in this one and then just sine in this one. So the sine times sine is what gives me the sine squared. So you're always going to have that. If you have a sine squared, you'll have a sine times sine. Or cosine squared, you'll have cosine times cosine. Here, since I had a 2, I just had to put a 2 in front of one of them. So now this for my plus 1. These 2 numbers are supposed to multiply to positive 1. And luckily, 1 is really, really easy to work with. There are 2 different ways that I could multiply to positive 1. Negative 1 times negative 1, or 1 times 1. Which one is it here, taking a look at my middle term? My middle term is supposed to be negative. Then it would have to be the negative ones. Good, so I'd have minus 1, minus 1. And you should always double check when you factor. Double check, make sure it actually FOILs back out the way it started. So here if I do first 2 sine times sine would give us the 2 sine squared. Outside term would be what? Negative 2 sine. Inside term? Negative 1 sine. So I have negative 2 sine, negative 1 sine. That's where the negative 3 sine comes from. And then my last term? Positive 1, which is what I ended with. So I factored it correctly, right? So that's the first part. That's the part that a lot of people have a little bit of a hard time with, is the actual factoring step. But then once it's factored, just like if you had x's, you take each piece and set those pieces equal to 0. Oops, minus. So take each factor, set it equal to 0. And then we're gonna solve just like we did up above. This time we're gonna give our answer in radians. Okay, so this sine is considered to be like your variable. So you wanna make sure that you get the sine part by itself. So if we start with this one on the left, what do we do to this first?
Add 1.
Add 1, good. So 2 sine theta. When I add 1 to the other side, I get this. Then what? Divide by 2 to get sine by itself. So I get sine equals 1/2. So that means I'm looking for angles that would have a sine of 1/2. Okay, so I'm going to put this back on the screen. We want to give our answers in radians this time. Okay, so go all the way around the unit circle. If there are repeats, or not repeats. If there are multiple answers, that's fine. Most of the time there will be multiple answers. So which angles do you see in radians that would have a sine of 1/2? Pi over 6, that's this one right here. So pi over 6 is the radian measurement. You can see right here the y value is 1/2. That's what we're looking for because sine is the y value, cosine is the x value. There's another one. 5 pi over 6. Good, same value over here. So this is my y coordinate of 1/2. So these two have the same y coordinate. So in radians, I would say pi over 6 as well as 5 pi over 6. So those are my first two answers. So I get pi over 6 as well as 5 pi over 6. So I got 2 answers. Let's see if I get some more from this one. What would I do to this? Add 1. So I have sine of theta equals 1. So same thing, I'm going to go back to my unit circle. I'm looking for any values of sine that are equal to 1. And it's not plus or minus this time because I didn't square root, it's just positive 1. So give me any angles in radians that have a sine of positive 1. Pi over 2, good, that would be this one right here. So pi over 2, this is a y coordinate of positive 1. It's the only one that has a y coordinate of positive 1 because if we look at this one y coordinate, there's only actually one place where it hits the circle. So pi over 2 would be an additional answer. So you'll definitely need your unit circle.